Okay, we're going to work on a problem from the stoichiometry dynamic study module. And so we're just going to work on the first one real quick. Assume 475 grams of acetylene, which is the C2H2, reacts with oxygen, O2, to produce carbon dioxide, which is CO2, and water, H2O. The problem requires that you... Oh, okay. What the hell? Oh, it doesn't show me the problem exactly, does it? Okay, right here. This is right here, right? This is what you see. God, this thing is just killing me. Okay, it's snapping for some reason, whatever. This is what you see, right? Right here? And then this, right? No? Okay. Wait, really? Because this question is select the missing conversion factor.
Like this is not the question that I have as first.
Oh, okay. What do you have as first?
What mass of
NaCl, okay. Okay. So what you're going to do here is what mass of AgCl will precipitate when 10 grams of NaCl is added to an aqueous solution, right? Okay, so you're adding aqueous solution of AgNO3. Does it give you the formula? Yeah, the reaction right here. Okay. Okay, so you have your NaCl adding to AgNO3, right? And so again, this is just a basic stoichiometry problem. You're looking for, so question mark, the mass of AgCl, right? So question mark grams AgCl. What you have been given is 10 grams of NaCl. That's what you're reacting and using up. And you've been given this reaction, right? So this reaction tells you how many moles of NaCl would give you moles of AgCl, right? That's what reactions do. And so is there a way to go from grams to moles? Yeah. And so we go to our periodic table, right? We look up and we get our molar mass. We want NaCl because that's what we're starting with, right? Mass of Na plus mass of a Cl. Got it.
So mass
The Na on the periodic table. Remember correctly, it's 22 point something plus 35. Yeah. And so somewhere around 57. Yeah. 58.44. Okay. And that's what units again? Oh, grams per mole. Notice the thing that should be going in the back of your head all the time. What do you have? What do you need? What do you want? Units, units, units. Because that's pretty much what every student gets wrong, right? And would make you actually be able to get the problem right. Okay, so now you have a molar mass. How would you go from grams then to moles?
So if I have 1 mole is 58, how many moles are 10?
Yeah,
Right?
you would have 10 grams. You can divide it by your molar mass, can't you? Yeah, and that would cancel out grams and give you moles. So the 10 divided by the 58, whatever. Worked out. Yeah, it's going to be some sort of fraction, right?
Yeah.
Decimal place. And that will be moles of NaCl. Okay, so once you have moles of NaCl, how are those related to AgNO3, or AgCl, I'm sorry.
Oh,
So 1 mole of NaCl would be
one
AgCl. So that'd be the same moles, right? That
yeah,
number,
so now we have to convert it to grams.
exactly. You got it. And so whatever that number was, what was that number? 0.0, 0.17, whatever. 0.17 moles. And it'll be a 1-to-1 ratio, so it'll just be 0.17 moles of AgCl, right?
Yeah, so if I have 0.1711 moles of
GCl.
GCl.
Now you need to get the molar mass for that. Yeah. Which, by the way, because these are all salts and ionic compounds, is actually called formula weight, if you're curious.
26. No, it's 80.
Yep. So you look up Ag on the periodic table, plus the Cl, which is like 140 or something like that. Okay. So that's like 143 grams per mole. Exactly right. So then you take your moles of AgCl, you'll then multiply it by that molar mass, so that moles cancel and leave you in grams, right? And that should give you 24. Go ahead. Yep, 24.5. Yeah, you got it.
I got it.
Mm-hmm.
And this will help me to understand better what we are doing before
Exactly.
in the
You got it. You got it. Exactly. The homeworks are sometimes easier than the dynamic study modules.
always.
Yeah.
Huh?
Yeah. Oftentimes, yeah.
This is mastery, like as it says, you'll get like an expert if you finish the dynamic framework.
Yeah, I often find.
I haven't forgotten how to do the molecular geometry or the redox oxidation because I mean I did like 25 or more.
Yeah. Yeah. Honestly, the homeworks make you competent that you could do it. The dynamic study modules give you that polish that you're going to be able to nail it on the
Like
test.
you just have to look at it and then write it down.
Yeah. Yeah, you're going to be
No more
polished,
than one
smooth
minute.
machine, right?
Yeah. Can we do another one like an approach?
Sure.
How many moles of
Yes. Okay. So how many moles of aluminum, Al, are needed to react with 4.7 moles of chlorine, Cl2? Okay. And so again, this is just the same sort of stoichiometry problem again. It's actually a little easier because now you don't have to do as many steps because you have 4.7 moles of chlorine, right? So you don't have to go from grams, you're already in moles. Yeah. And so you have 4.7 moles of chlorine. Well, we use our little ratio here, right? So if we have 3 moles of this has to react with 2 moles of that, then 4.7 moles of this, reverse. Use your units. You have 4.7 moles of Cl2. So to get rid of Cl2, you'd have to.
Multiply by AL and then you divide by CL.
Exactly. Yeah, you'd have to multiply this 4.7 moles of Cl2 by the 2 Al, because you want to get into Al. And then divide by the 3 Cl2s. And that'll get rid of your Cl2s. And leave you in moles of Al. And that actually finishes that. Because that one actually was pretty straightforward and easy, wasn't it? So that would give you your 3.1 moles of AL when you do that. Yeah, we ended up cutting out the front and the end steps.
Can we do another test?
Sure. Let me go ahead and close this and